All right, the Taylor series for a function f about x equals 0 converges on the window from -1 to 1 inclusive uh, with the nth degree Taylor polynomial for f, excuse me, about x equals 0 being given by this lovely summation, p sub n of x equals a bunch of stuff and things, on the following, of the following, which is the smallest number m for which the alternating series bound guarantees that the approximation using the Taylor polynomial, the fourth degree Taylor polynomial for 1, that the approximation is within M. Okay, so the short version here is alternating series error bound is just the n plus 1th term, right? So if you're using p sub n of x, the error is the nth plus 1 term. So since we're using p sub 4, this is literally going to be the n equals 5 term at x is 1, right? That's it. Guaranteed. That's all they want. So if I go ahead and plug in 5 for k, right? So, or yes, it's not n is 5, it's k is 5. It doesn't really matter. So k equals 5. The k is 5 term in this situation. So I'm going to get -1. It's in the absolute value, right? It's the absolute value of the nth term. But so -1 to the 5th, right? 1 to the 5th, because that's what my x is here, is a 1, right? Over 5 squared plus 5 plus 1. So this is definitely a 1 over 31, and that's the limit of the error. So alternating series error bound is literally just the n plus 1th term, right? So if you're using the fourth degree Taylor polynomial, it's going to be the 5th term. If you're like the n equals 5 term or the k equals 5 term. If you're using the 27th degree Taylor polynomial, then you're using 28. You're plugging 28 in. It's literally always just the n plus 1.